So security rules are pretty great. They're one of the main reasons we're able to pull off this whole serverless computing thing in the first place. I mean, if you think about it, if we just gave your clients like an API key that had full access to your database, it would be a nightmare. Like any malicious user could make any kind of call they wanted to your poor defenseless database. And so to fix this, you'd basically have to go and set up your own intermediary server that would like process each request and then talk to the database while making sure it's only accessing the data that your clients are allowed to see. Well, with security rules, none of that is needed, right? You can run your entire app without ever needing to set up a custom server if you don't want to. And that's why our episode is called Security Rules, like the noun, but also Security Rules, like the verb. Grammar jokes. Wait, where are you going? Come back. Okay, so let's talk security rules. And first, let's talk about what we are not going to talk about. We are not going to cover security rules for requests coming from server libraries, and yes, that also includes cloud functions. And that's because these libraries can get away with a whole lot more. I mean, you're probably not letting any random user in off the street to log into your server. And, if you are, stop it. So server-side apps are generally able to bypass all the security rules that I'm going to be talking about today. If you want to provide security on top of any of these server libraries, those are covered by a completely different system called IAM, as in I am not going to talk about server-level security in this video. All right, so with that out of the way, let's talk about clients and security. Now, the overall philosophy when it comes to securing your database against client requests is really that you should never trust your client to be doing the right thing. I mean, sure, maybe you've written some nice client-side code to perform some validation, maybe you've even tested it, but all that code is just kind of sitting there on some mobile device or web browser, kind of at the mercy of your user. And it's generally pretty easy for some evildoer to either modify the client request to do something you didn't expect, or create a fake request that looks like it's coming from your app but isn't really. So we need to protect your data with the assumption that your clients aren't going to be doing the right thing. So you can think of security rules as being something like a bouncer at your local nightclub. All these client requests want to go live it up at like cloud database, but your security rules are there at the front door, letting in the database requests that seem cool while rejecting the ones that don't meet the dress code. So let's see how our bouncer does its work. Now, any request coming in is probably going to involve a document, right? You're either reading one, creating one, updating one, or trying to get a bunch of them out of a collection. Cloud Firestore is going to look for a set of security rules that apply to this document. And then it's going to run a set of tests, the rules that you as a developer specify, to determine if this request is allowed. And actually, that's basically all it is, right? Your security rules are going to consist of specifying what specific documents you're securing and then what logic you're using to secure them. So what does that look like in practice? Let's take a look. For starters, from the security rules perspective, all documents fall under the path of database / your database name / documents, followed by the actual path to your document. Meaning that if you have a document at restaurant / Todd's Tacos, it's going to look like database / your database name / document / restaurant / Todd's Tacos. And that's generally why when you first see your rules, they're set up to look like this by default. This database thing in curly brackets, it's basically a wildcard that's saying, go ahead and match any database name you encounter here. And when you do, go ahead and assign it to a variable that we're going to call database. And I'll talk more about these wildcards and variables in a minute. Now, you're going to be dealing with a lot of hierarchical data, and writing out full paths for all this data would probably start to get kind of annoying and probably error prone. So Cloud Firestore lets you nest your paths. So almost always you'll see database / database / documents as like your outer level match. But then in our restaurant review app, for instance, I could specify the documents in my restaurant collection like this. And then instead of having to specify my restaurant reviews like this with the full path, well, then I could nest them inside my restaurant reviews like so. And remember how in the last episode I talked about how my restaurant might want to have like a private data subcollection? Well, I could add a separate block for that here. Now, the look of these nested rules can be a little misleading because you might think that rules you add at this top level would cascade all the way down to these other subcollections, and that is not the case. Unlike the real-time database, security rules in Cloud Firestore don't really cascade. And in my case, this is probably a good thing. I don't want the same rules at the restaurant level to apply to documents in the private data collection or to my reviews. Incidentally, you might have noticed that I'm specifying documents here throughout my rules and not collections, and that's basically going to be true for all your security rules. Like if I tried to create a rule like this to secure my restaurants collection, I probably wouldn't want to write it this way. I mean, yes, technically it might work, but it's considered much better form to start with the restaurants collection and then add this wildcard here to basically represent any document that's inside this collection. Oh, hey, that's a good transition. Let's talk a little more about these wildcards. So there are two types you're going to see. The first is this one we've been using, the one in curly brackets. And you're basically going to use this to say, go ahead and match a single path element, either a document or a collection, and stick it into a variable with the name that I've specified here. So within this block here, I'll have a variable called restaurant ID that's going to match the actual document ID of the restaurant document that I am trying to access. And down here, I can still access that restaurant ID variable along with a new review ID variable that equals the document ID of the review. Now, usually I can just access these variables directly like so, but there are a couple of exceptions that you will see later. Now, the second wildcard you're going to be using is a rest of the document path wildcard. It looks almost the same as our first wildcard, except we've got this like equals star star thing afterwards. Now, this wildcard basically says, go ahead and match the rest of the path and stick it into this variable here. For example, if I added this line here, it would match every document in my user's collection, but also every document in every sub-collection. Now, one thing you do need to watch out for is if you use this type of wildcard, the value will literally be the rest of the document path. So the value of my rest of path variable could be my user ID, but it could also be like my user ID /history ID, depending on where I'm looking in my database. So be careful if you're actually expecting to use this value as just the user ID, it might change. One last thing to note is that rules written with these recursive wildcards are ORed in with the rest of your rules, which means in a situation like this, that bottom block won't actually have any effect whatsoever because this action has already been allowed by the recursive block written above. So it turns out two of the most common situations I see where these recursive wildcards are being used is either when developers want to cover a document and all of its subcollections by the same rules, or if they want to temporarily make their database completely open by adding a block like this to the top of the rules. And if you're one of those people who's done that, that's fine for development. Just please make sure you remove it before you ship. Okay, so we've basically figured out how our metaphorical bouncer is going to read the guest list. How do we now find out whether he's going to let those requests in? Well, you're basically going to need to provide a Boolean value for each specific action. And there are basically 5 actions that you should be concerned with. Get for when a user requests this specific document. List for when a user runs a query that might return this document. Create for creating a brand new document. Delete for deleting it. And update for updating a document that already exists. Now, these first 2 can and often are combined into a single action called read, and these last 3 can be combined into a single action called write, although I think it's a little more common to see those broken up. Now, as for the Boolean values, well, sometimes you'll just be explicitly returning true or false. Like, let's say you've got some documents that you've decided, hey, everyone in the world can read them. Well, you can write a rule like this, or even simplify it to this, and voila, they are publicly readable. Or maybe you've got some read-only documents that you don't want any client to be able to modify, then you might add a rule like this. But I'd say most of the time you're probably going to be adding some fancier conditional logic, and you'll probably be making your decision based on one or more of these 3 pieces of data. 1, the data request that's coming in. 2, the document in the database that you're looking to either read or update. Or 3, some other data located in some other part of your database. So let's take a look at these one at a time. Now, I am not going to be able to fit everything you can do with all this data into this video, so I do recommend that you read the documentation on all this, both our guides and also the reference documentation, which, is actually pretty readable as reference documentation goes. So the data request that's coming in is going to be referred to as the request object. It's got a bunch of properties attached to it, but the 2 most common you're going to be looking at are the auth object and the resource object. Let's take a closer look at each of these. So the auth object contains information about the signed-in user, assuming you've authenticated them using Firebase auth. And because it's all been verified server-side, you can generally trust it. So what kind of stuff can you find out? Well, whether they're an actual signed-in user, that's pretty common, or their user ID. That's actually very common too, and we'll be using this a lot in some upcoming examples, so stay tuned. You can also grab some claims made by their auth token, like what the user's email address is, and if that email address has been verified. You can also create your own custom auth claims, which I'll talk about a little later because, it's kind of advanced. So forget I said anything for now. So if I wanted to say, hey, you can read this data, but only if you're signed in, well, I might write a rule like this. And if I wanted to say, I'm only going to make this data readable to people with the google.com email domain, I could do that here. I'm specifying the email domain and also requiring that the email has to be verified by our auth system. And if I wanted to say only Albert can read this data, well, I could add a rule like this, assuming this is Albert's user ID in our system. Now, as for the document you're going to write to the database, it's going to be represented as a request resource object. Now, it's also got a few metadata fields that you might be interested in, but most of the actual content is in the request.resource.data property. This data property represents all the fields of the document that your user is trying to write. It's a dictionary or a map, which means you can access any of the individual fields either directly like this or using brackets notation like this. And so you know how back in video 1 I said that Cloud Firestore was schemaless, meaning you can basically kind of put any kind of data anywhere? Well, you can use security rules to help make it a little more schema-full, I guess, by ensuring that certain fields contain certain values by looking at this object. Like, let's say I'm looking at the security rules for creating a new restaurant review. So first off, let's make sure this is under the create action. And then I'll want to say, you know what, let's make sure our score is a number. So I'll do that by making sure request.resource.data.score is a number. This incidentally will also mean that null values are not allowed since null is not a number. While we're at it, we can also add these lines to ensure that it's a value somewhere in between 1 and 5 stars. As for the headline, well, maybe we'll want to make sure it's a string, and maybe it's got to contain between somewhere like 2 and 200 characters. We could do the same for the text of the review. You kind of get the idea. Now, these are probably rules I'm enforcing at the client level anyway, but again, when you're talking about security rules, it's best to assume you can't trust the data that's coming in from the client. And then here's the important one. I probably want to say that somebody can only submit a review if the value of the reviewer ID field is the user's actual user ID. Like, you don't want your user to be submitting restaurant reviews on behalf of some other random person, right? That could cause all sorts of trouble. So by adding this rule, I can make sure that you are only allowed to create a review if you list yourself as the official author, and that's verified by Firebase auth. So nice way to add some simple data validation, right? Okay, let's take a look at the second piece of data you might be dealing with, and that is the resource object. Sounds kind of similar to the request.resource object, right? And it is. The difference is that while this one here represents the document you're trying to write, the plain old resource object represents the document that's already there in the database, either the document you're trying to read in or the one you're going to update. And like the request.resource object, you have a few properties that correspond to some metadata. And then more importantly, you have the .data property, which can be used to access any of the fields within this document. So let's go back to our example. Let's assume we want our users to have the ability to edit restaurant reviews after the fact, which they will do by updating the old review document. So what kind of security rules would we want to add here? Well, like before, we'll want to do some validation to the request.resource object. That's the object you're writing. And if seeing all this redundant code has your programmery sense tingling, hang on, I'll cover that in a bit. But now there's an important rule we're missing, which is that you can only edit your own restaurant reviews. After all, we can't have you overriding other people's reviews, right? So how would we enforce that? I think by saying that you can only update an existing document if your user ID is equal to the reviewer ID that's already there in the database. And that's something we can do by looking at the resource object. So I'm going to say here that the signed in user's ID has to be the same as the reviewer ID of the resource. That is the document already in the database. Something like this. With the resource object, I could also add a rule that says something like, hey, maybe you can't change the score of the review by saying that the value of the request resource has to equal that of the currently existing resource. And this is a pretty common rule that you as a developer might want to set, like marking certain fields as not changeable once they've been created. By the way, you might be wondering, well, gosh, will this still work if like my client app only sends down a new headline? Like, do I have to worry about these other fields being null? And the answer is no. See, my request.resource object represents the document as it might look like in its final form after the rights have been applied. Technically, the team likes to say that request.resource is hydrated, which I suppose is better than my original suggestion of moist. Okay, let's keep going and start looking at document reads. Specifically, I want to look at the difference between getting one individual document and querying a bunch of them. As an example, let's assume reviews can be in two states: draft, meaning the user is still in the middle of writing them, and published, which means they have been published to the world. Well, we probably want to make sure that you can't view any draft reviews unless, like you're the author so that you can finish working on them. So I could add a read rule that looks like this. You can read a review if the state is equal to published, or if the reviewer ID is our signed in user's user ID. Seems straightforward, but I want to talk about this one a little more because I want to clear up one of the ways security rules work. For starters, you can't use security rules to automatically filter out a list of documents for you. For example, I can't say, hey, just give me all restaurant reviews and expect that security rules will automatically filter out the reviews that are in draft mode for me. In fact, really, when it comes to queries, we're validating the query without looking at the underlying data at all. See, when I'm running queries to try to retrieve a bunch of documents, security rules doesn't have the time or bandwidth to analyze each individual document for me. Not if we want to keep this thing scalable and fast for, billions of documents and billions of users. So instead, it's going to look at my query and try to prove that it would be allowed based on my security rules, no matter what might be in the underlying data. So, for example, saying get all restaurant reviews will return a permission denied error because security rules is looking at this request and saying, well, I could see that there are cases where this request would be denied, even if it turned out that in my particular request, all the restaurant reviews I was trying to query happened to be public. Now, on the other hand, if I change my request to get all restaurant reviews where state equals published, then security rules will be able to analyze my request and determine, yes, there's no way this request could fail. And then it will return the documents for me. And again, it can do this without having to look at the underlying data. Now, to be clear, this only applies to query types of requests where you're getting a bunch of documents from a collection. If you're just requesting one specific document, then yes, security rules will take the time and effort to analyze the individual resource you're trying to retrieve. Okay, finally, let's look at the third common chunk of data you're going to be evaluating, and that's arbitrary documents in the database. Now, typically, you'll be accessing these either using the exist function, which checks to see if they exist, or the get function, which will return an object that looks an awful lot like the resource objects we've been dealing with earlier. In fact, just like those objects, the thing you get back from a get call has a data property that security rules can use to read in any field inside this object. So when would you use this? I think the most common case will be where you want to store a list of users who have access to a specific document within your app. This will be data you're going to want to store somewhere in your database, and then you can look them up later using these security rules. For example, maybe for every restaurant, we have a list of editors, like people who are allowed to edit details about that particular restaurant. And following the advice of our previous video, we stuck it into a private data subcollection, something like this. So let's say I want to establish a rule that says you can only edit a restaurant document if you're listed as an editor inside this private document. Well, here's how we do that. First, I'm going to specify that this applies to documents inside a restaurant's collection. Now notice that I can grab the restaurant ID from this wildcard here. So I can pretty easily create a path that points to the restaurant's private data/private document. Actually, maybe this isn't quite as simple as it first looks. There are two little quirks here. First, notice that this path here isn't a string, even though to me it kind of feels like it should be. And because of that, also notice that I got to use this $ parentheses thing for my variable to make sure the get function knows that I mean to use the restaurant ID variable here and not an actual string called restaurant ID. So now, once I've grabbed this document, I can access its fields by looking at the data property. Then I can specify that I'm interested in the roles field, and I could say something like, hey, make sure our user ID is listed as an editor by adding something like this. Or maybe I could get fancy and change this to give this ability to multiple roles. So while I generally like this current approach where we have a bunch of different documents or collections that might have a bunch of different users with read or write access, sometimes you might have more global level permissions. Like our restaurant app might have a moderator who can edit all reviews, or a super admin who can edit all restaurant info. For those kinds of global permissions, another option you can consider is creating custom auth claims. These are essentially custom variables that you would set for a specific user using a server-side library or cloud functions. You could then retrieve these values through the request.auth.token object. So like I might write a server call like this that makes me a super admin. Then I could add a security rule here at the top of my documents that says, hey, you know what, super admins, they can read and write anything. Or add this one at the reviews level that says moderators can read or write any review. Now, obviously, these rules are quite powerful and they come with a few restrictions. First, you got to have your user refresh their access token to get these new permissions, which means signing out and signing back in, or I think now they can just wait an hour and get the new permissions. Second, there's a limit to how many of these custom auth claims you can make. And third, you're going to need some kind of server code or a cloud function to write them, which is why I really like using them more as sort of app level permissions and not like, hey, this one specific user can write to this one specific document kind of permissions. If you kind of want to go back to that, use the trick I was talking about earlier with a get call. But these custom auth claims, they are super useful for those kinds of app level permissions without your needing to write a bunch of redundant code. Hey, speaking of redundant code, maybe you've started to notice that my security code, it's starting to look a little messy and it's kind of redundant. Also, it's repeating itself. I'm sorry, only one of you guys is on the list. We're gonna have to kick out 2 of you. Can we? Thank you. Luckily, security rules has a nice way of helping out here, and that's by letting you write custom functions. Now, for the most part, these are just functions that have one single return statement, but they are super helpful, both for avoiding redundant code and for making it clear what you actually want your security rules to do. For example, this "is my user a restaurant editor" logic is probably something I could see myself reusing in other places, so I can move it to a custom function. Now, if I were to define the function here, inside the block where restaurant ID is already defined, I can reference the restaurant ID variable from within the function. If I were to define it outside the block, maybe because I like to keep my functions and matching rules nice and separate, then I need to pass in the variable like this. Which way is better? I don't have a strong preference either way. I guess I kind of like having the functions close to the documents they'll be referring to, so I usually write them this way, but you do whatever you like. Similarly, I can check and see if my request.resource is a full and valid restaurant review with this kind of function. And in fact, I might also consider replacing these lines with functions that describe what they do a little better, something like this. I'm not really saving any lines of code, but when I come back to my security rules 2 months later, I'll have an easier time understanding the point of my code just by looking at these function names. And now that I've done this, I can actually see that I'm missing a rule where I forgot to add my state field to my security rules. Well, now I only need to do that here, and I just do it once. And notice how our sort of complicated update logic is a lot clearer now. So this is looking like a good start. Now, obviously, these rules aren't totally complete yet. I haven't added rules for like creating new restaurant documents or deleting everything. I probably should do that before we ship, but it's a good start. So rules are super powerful, and with custom rule functions, you can add some pretty sophisticated and complex rule sets without things turning into too much of a mess. What are the drawbacks? Well, I think the biggest one right now is testing and debugging these things can be complex, particularly in a production app where if your request is denied, you just don't get any explanation as to why. I mean, that kind of makes sense from a security standpoint, but it's still pretty frustrating from a debugging standpoint. Luckily, Cloud Firestore now comes with a rules simulator that lets you test out any operation against your security rules. So you can add your security rules and then make a number of simulated calls against them, even when they're in draft form. The console will tell you when these calls succeed and what rule allowed them, or when they failed and what rule blocked them. That said, the simulator is still fairly new, and I've run into a few cases where the simulator acts slightly different than the actual underlying rule system. And while the simulator is useful for testing calls during development, it's generally not so great for unit testing. Luckily, hopefully, by the time you see this video, there will also be a Cloud Firestore emulator, which essentially lets you run an instance of Cloud Firestore locally, specifically so that you can run unit tests against all of your security rules and make sure you don't make any changes that accidentally expose data that you hadn't intended. Whew! Well, that was an awfully long video, and I think we made it to the end. We should celebrate. I know! Let's go clubbing! Aw, what do you mean sandals aren't part of the dress code? I paid like $12 for these. Fine, you know what? This place is dead anyway. Come on, guys, I know a better place around the corner. As for the rest of you, I'll see you on another exciting edition of Get to Know Cloud Firestore. Hey, wait up!